Okay, 7th graders, today we're going to talk about finding experimental probability. And the experimental probability is similar to theoretical. Theoretical is what should happen, experimental is what does happen. So the experimental probability is the number of times an event occurs all over the total number of trials that you did in your experiment. So experimental probability is the number of times it actually happens over the total number. Theoretical probability was how many times something should happen over the total number of options. So they're really similar. Experimental probability is just what does happen. Theoretical probability is what should happen. So if we look at this first problem, 13 out of 20 emails in your inbox are junk emails. What is the experimental probability that your next email is junk? So the number of times the event has occurred is 13 are junk. The total number of emails that you have is 20. So the experimental probability that your next email is junk would be 13 out of 20. You may be asked at some point to write your probability as a decimal or a percent. So 13 out of 20 would be 0.65 or 65%. However, unless you're asked, fraction will suffice. Fraction is fine as long as you're not asked for something else. So what is the experimental probability that your next email is not junk? So if this is the probability that it is junk, the probability that it would not be junk would be the other 7 would not be junk out of 20. And then 0.35 or 35% if you were asked to do that. If not, you can just leave the fraction. Alright, moving on to the next page, or the second half of that page, sorry. It rains 2 out of the last 12 days in March. If this trend continues, how many rainy days would you expect in April? So, there are 2 out of 12 rainy days. 12 would be the total number of rainy days. And to figure out how many days it would rain in April, or that we would guess that it would rain in April, we have to do the total number of days in April, which is 30, I believe. And we can solve this in multiple ways. We can either reduce it to 1/6, so 1 in every 6 days would be rainy, or 5 out of every 30 days would be rainy. Or we could have set these equal to each other, cross-multiplied. 2 times 30 is 60, divided by 12 would be 5. Now be really careful that you don't leave your answer as 5/30ths. So that, because if that were your answer, that's a fraction that says, well, 5/30ths of a day in April would be rainy. But that's not the case. It's 5 days total. So you want to make sure you really have that down as your answer and don't just leave the fraction. On the next one, at a clothing company, an inspector finds 5 defective pairs in a shipment of 200 jeans. What is the experimental probability of a pair of jeans being defective? So 5 out of 200 are defective. You could leave that. It's better if you reduce it. They can both be divided by 5. So we get 1/40th. About how many would you expect to be defective in a shipment of 5,000 pairs of jeans? So we can either take the 5/200ths or the 1/40th and set it equal to 5,000. So I'm going to take the 1/40th. set it equal to 5,000. 5,000 divided by 40 leaves us with 125 pairs of genes that would be defective. That's a lot. Alright, on to the back page. The bar graph shows the results of rolling a number cube 50 times. What is the experimental probability of rolling an odd number? How does this compare with the theoretical probability of rolling an odd number? Okay, so, what is the experimental probability of rolling an odd number? So, we had, on our bar graph, 1 is odd and it was rolled 10 times. 3 is odd and it was rolled 8 times. 5 was odd and it was rolled 8 times. So, the experimental probability of rolling an odd number is 10 plus 8 plus 8, which is 26. And the bar graph shows the results of rolling a number cube 50 times, so 26 out of 50 is the experimental probability. The theoretical probability of rolling an odd number is, if I have a number cube, 1, 3, and 5 are odd, so the experimental probability is 3 out of a possible 6. So how do the two compare? Well, 3/6 we know is just 1/2. And 26/50ths would be close to 1/2. So those squiggly equals signs are about, or close to. So I would say that the probabilities are similar. They're really, really pretty close. Alright, on the next one, what is the experimental probability of rolling a number greater than 1? So the experimental probability of rolling a number greater than 1 would be 2, 3, 4, 5, and 6. So 5 out of 6 is the experimental probability. How does this compare? That's the theoretical probability. The experimental probability would be that there are 4 2s, 8 3s, 11 4s, 8 5s, and 9 6s. So if I add all of those up, the experimental probability is 40/50ths, because it rolled 50 times and we got 40 greater than 1. Theoretical was 5 out of 6 rolls should be greater than 1. And how do they compare? Well, if we're going to take this out of 50 rolls, or if we're going to see how 5, 6, and 40/50ths compare, we can figure out of 50 rolls how many should be here by doing 5, 6 equals some number out of 50. So 5 times 50 divided by 6 gives us almost 42. So what would you say about the theoretical probability and the experimental probability? Did the experiment have about the results you would think it would have? Yes, they were similar. we came out pretty close to 42. We got 40. Alright, so your homework is to do those last 4 problems based on the bar graph that is given. And as an excellent surprise and happy I guess ending to your notes video, we have our friends from one of the 7th grade classes. And they have special messages for you. Anybody with a special message?
Hello. Hashtag lamppost.
Stop!
I have a special message.
I heart New York pizza.
Cupcake. I'm the one in the white shirt.
Ignore the one in the white shirt, please.
Ignore the one they can't be seen.
What are you
Don't
talking
ignore
about?
me. I'm the one with the jazz hands.
Fool.
One in the white shirt's the best.
Draw a mustache on the one in the white shirt. Oh, no, you don't.
Oh, yeah. That's right.
Oh. Dang it.
You died.
Doesn't matter.
You're dead.
Oh, God.
Yeah, that was alpaca.
White shoes, alpaca, unicorn, moose, alpaca, moose, moose, alpaca, unicorn, fish.
This is the math